Okay, this is section 1.3 on linear equations. So if you remember back in algebra, we first learned about slope-intercept form after we plotted points and graphed lines or any equations the old-fashioned way. We learned a trick. So slope-intercept form of a linear equation is y equals mx plus b, where m represents the slope. And if you remember, slope is rise over run, how much it goes up and down over how much it goes left and right. The formula for slope is y1 minus y2 over x1 minus x2. And then the b in the equation is your y-intercept, where it crosses the y-axis. So we learned this shortcut that if the equation is in y equals mx plus b form, we can graph the y-intercept and then go use the slope to go up or down, left and right in the correct direction and plot another point. Then we can connect the dots and create our line. Okay, the next formula is the point-slope formula. If you're given a point and a slope, you can plug into this formula and find the equation of the line. So y minus y1 equals m times x minus x1. The only thing you're going to plug into this formula is the m and the x1, y1. The y and the x that are plain stay as they are. Those are just variables in the equation. And then we have standard form. And standard form is not a formula. It's not something you plug into. It's just something that you use. And you rearrange your equation to look like standard form. So standard form is ax plus by equals c, where x's and y's are on the same side of the equation, x is positive, and there shouldn't be any fractions in the equation. So next we're going to look at parallel lines, and in geometry you learn that parallel lines don't intersect each other, so that means that they have the same slope. They rise and run the same amount. Then we have perpendicular lines that intersect at a right angle. Perpendicular lines have slopes that are negative reciprocals. And the way I remember how to find the negative reciprocal is just to flip it and change the sign. So whatever your slope is of one equation, you just flip it over and change the sign, and that will give you a perpendicular slope. Vertical lines are always going to be x equals some number. And they have an undefined slope because they're going up infinitely, but they're never going over, so it's undefined. Horizontal lines have the equation y equals some number. They have a slope of 0 because they're not going up any, but they continue to go over infinitely. Okay, so let's look at these examples. Number 1 wants us to write the equation of a line that contains the points 3, 6, and negative 6, 0. So first thing we need to do is find the slope of this line. So our slope formula is y1 minus y2 over x1 minus x2. So I'm going to do 6 minus 0 over 3 minus a negative 6. So that's going to give me 6 over 9, which reduces to 2/3. So now I'm going to use my point-slope formula. I have a point, and I can use either one, but I'm going to use 3, 6 as my x1, y1, and I have a slope 2/3. So I plug those into the formula where they belong, and then we'll simplify. So this is going to be y minus 6 equals 2/3 times x minus 3. So to simplify, I'm going to distribute the 2/3. So y minus 6 equals 2/3 x. 2/3 times negative 3 is a negative 2. Then I want y by itself, so I'm going to add 6 to both sides. So the equation is going to be y equals 2/3 x plus 4. So this line goes through the points 3, 6, and negative 6, 0. It has a slope of 2/3, and it also has a y-intercept of 4. Okay, number 2 wants me to write the equation of a line that's parallel to number 1 and goes through the point 5, 2. So if it's parallel to example 1, then its slope is also going to be 2/3. And 5, 2 is going to be our x1, y1. So we're going to plug into the same formula. Y minus 2 equals 2/3 times x minus 5. So we're going to use the same process to get y by itself. I'm going to distribute and multiply by 2/3. So y minus 2 equals 2/3 x minus 10 over 3. I'm going to add 2 to both sides. So I'm going to get y equals 2/3 x minus 4/3. In your calculator, you can do negative 10 over 3 plus 2, and then math, enter, enter, and it will change it back to a fraction for you. Okay, so this is the equation of a line that is parallel to example 1, has the same slope, which was 2/3, but this time it goes through the point 5, 2. Okay, our last example wants us to write the equation of a line that is perpendicular to example 1 and goes through the point 5, 2. So the slope of example 1 was 2/3. For the perpendicular slope, you're going to flip it and change the sign. So that's going to be negative 3 over 2. And our x1, y1 is still going to be 5, 2. So when I plug into point slope formula, y minus 2 equals negative 3 over 2 times x minus 5. I'm going to distribute the negative 3 over 2. So y minus 2 equals negative 3 over 2x plus 15 over 2. I'm going to add 2 to both sides. So that would give me y equals negative 3 over 2x plus 19 over 2. So if they were asking for the problem in slope-intercept form, then this would be my answer. Some of the problems in the homework will ask for standard form. So let's rearrange this and get it in standard form. Standard form has x's and y's on the same side. X should be positive and there should be no fractions. So first thing I would do is move the x to the same side as y. So that's going to change it from being a negative 3 over 2 to a positive 3 over 2x. Okay, sorry about that. Positive 3 over 2x plus y will equal 19 over 2. Now we don't want any fractions, so to clear out the fractions, we're going to multiply everything by the greatest common denominator, which will be 2. So when I multiply everything by 2, then you're going to get 3 over 2x, or the 3 over 2 times 2 will become 3x, plus 2 times y will be 2y. 2 times 19 over 2 will just become 2. So now this is in standard form. X's and y's are on the same side, x is positive, and there are no fractions.